Right, this is part 7 of the accumulating functions and the fundamental theorem of calculus. This is a pretty lengthy FRQ. Lots of work involved here, so we'll jump right into it. So the graph of a function f consists of a semicircle and two line segments as shown above. Let g be the function given by g of x equals the integral from 0 to x of f of t dt. So the first thing to note here is that f is equal to g prime. So if I take the derivative of g prime of x, it'll just be f of x. Okay. So find g of 0 and g prime of 3. So let's start with g of 0 would just be the integral from 0 to 0 of f of t dt. And the integral from 0 to 0, we know by the 0 property, is just going to be 0. G prime of 3, because again up here we said g prime is equal to f, then g prime of 3 is just f of 3. And according to the graph, f of 3 is -1. B, place the following in order from least to greatest: g of -2, g of 2, g of 4, and g of 5. So we're going to find these four areas. We can use the information we get from the first one to help us figure out everything else from there on out, and then we put them in order from smallest to largest. So let's start with g of -2. So we're looking here at the integral from 0 to -2 of f of t dt. So from 0 to -2, first of all, we are going to the left, so it's going to be negative. And we're looking at a quarter of a circle, so that would be 1/4 times pi. The radius of this circle is going to be 2, so 2 squared. So 2 squared is 4, 1/4 of 4 is 1, so we end up with just -pi as the integral from 0 to -2. How about g of 2? So now we're doing the integral from 0 to +2 of f of t dt. Well, the first thing you should notice is from 0 to 2 and 0 to -2, the area is going to be exactly the same, except here we're going to the right, so the area would just be +pi. G of 4 would be the integral from 0 to 4 of f of t dt. Well, let's see. The integral from 0 to 4 would just be the integral from 0 to 2, which is pi, plus the integral from 2 to 4. So I'm going to write that as pi because of that area. This area is negative, so we are going to have to subtract it. And this whole piece right here is just a triangle, so it's going to be 1/2. The base is +2. The height is 1. So I get pi -1 for the integral from 0 to 4. And then g of 5 is the integral from 0 to 5 of f of t dt. Which again, same thing. We're going to look at the integral from 0 to 4, which we now know is pi -1. And we're going to add on the area from 4 to 5. This is a triangle, base 1, height 1. So it's going to be 1/2, 1 times 1. So we get pi -1 plus 1/2, which is pi -1/2. So let's go ahead and put these numbers in order from least to greatest. And we'll do that right here. So let's see here. We have -pi, +pi, pi take away 1, pi take away 1/2. So we know -pi would be the smallest, as that's going to be the only negative value. So g of -2. And then we have pi -1, and pi -1/2. Well, pi -1 would have to be the next smallest, so g of 4. Pi take away 1/2 would be next, g of 5. And then pi would be the largest, so g of 2. That's a very involved question, lots of parts to that. C, find all the values of x on the open interval -2 to 5 at which g is a relative maximum. So again, what we're looking for here is where g prime, which is f, is 0 and changes from positive to negative. So I go back up here to the graph. The only time that f is 0 is at -2, +2, and +4. But the only time it changes from positive to negative happens at x equals 2. So all the values of x on -2 to 5, x equals 2, has a relative maximum because f, which is g prime, is 0 and changes from positive to negative. Okay. Next, find all the values on the open interval -2 to 5 at which g is concave up. So I'm going to say g is concave up implies that f prime is increasing, or f double prime, the slope of f prime, is positive. So come back to my graph. My graph is increasing. This is f. It's increasing from -2 to 0, and it's increasing from 3 to 5. Or if you want to go the slope is positive from -2 to 0 and from 3 to 5. So -2 to 0 and 3 to 5, because g, which equals, or g prime, which equals f, is increasing. I should have said that up here, that this is f is increasing and f prime is greater than 0. Okay. And then part E, let h be the function given by h of x is equal to the integral from 0 to x of f of t plus 2. Find h of 4. So h of 4 is going to be the integral from 0 to 4 of f of t plus 2 dt. Well, by the addition property, that would be the integral from 0 to 4 of f of t dt plus the integral from 0 to 4 of 2 dt. So the integral from 0 to 4, if we come back up here, the integral from 0 to 4, we already figured that out up here to be pi minus 1. So we can take that value of pi minus 1. And then the integral of from 0 to 4 of 2 dt, again, you've got to think of that as the graph of 2 is a horizontal line. We're trying to find the area from 0 to 4. So that becomes a rectangle. Its area is 8. Pi minus 1 plus 8 is pi minus 7. And that finishes that problem.